Hey, it's Mr. Pomeroy here, and I'm making this video to help students with thinking with mathematical models, Investigation 1. The big ideas in this first investigation are recognizing linear and nonlinear patterns in tables and graphs and using these patterns to make predictions. Throughout this book, students will use tables, graphs, and equations to explain real-life situations. This video is designed to be helpful to students and parents for the first investigation in our book. Feel free to pause the video at any time. Some people like to watch the video before they jump into the problems and the homework, and other people like to do a little bit of the homework and then check as they go. Use this video however it helps you. This is the third in a series of 4 videos and specifically deals with problem 1.3. So next, students investigate problem 1.3, and they're introduced to a company that builds things out of steel rods, like these steel rods right here. Now, they build 2 types of things. They build beams out of those rods and staircases. So the beams are made out of these rods welded together in triangular patterns, and you can see the patterns shown here in the book. And students are asked to look for patterns as this data is put into tables. So a 1-foot beam is made from 3 rods and makes 1 triangle. A 2-foot beam takes 7 rods, and it's 2 triangles kind of hooked together by another rod, sort of making 3 triangles, but 2 triangles along the bottom. And a 7-foot beam is made from 27 rods, and so on. Now we can make staircases with these rods as well, and down below is a different pattern for staircases. 1 step on the staircase is made with 4 rods, whereas 2 steps requires 10 rods, and 3 steps requires 18 rods, and so on. So students are asked to use the drawings in the book and make their own diagrams as well to complete a table for each of the situations for the beams and for the staircase frames, and to be looking for patterns. Then they're asked to graph the data and look for patterns. So students are recording the same data in both a table and a graph, and ultimately they're also looking for an equation. And they're looking for the rule or the equation for the situation so they could find the number of rods it would take for any length of beam. For example, in question 5 it asked for a length of 50 feet, and so on. In this unit of study, students are expected to express data in tables, graphs, and equations. Now I'll quickly go over the answers to problem 1.3 that students should have arrived at once they've completed the problem. When they make the table of data, it should look like what happens here on A1. And you'll notice a pattern. As the beam length increases by 1, the number of rods required to make that increases by 4. So we have a linear pattern, and the constant rate of change is 4, and hopefully students start noticing that from a table. We can also see that from the graph, where as every time the beam length increases by 1 foot, the number of rods increases by 4 in a straight or linear pattern. In question 3 and 4, students are asked to explain that in their own words. And in question 5, students are asked to find the number of rods required for a 50-foot beam, and we had a good class discussion on how they came up with that rule or that pattern. Ultimately, we were hoping that students would come up with this equation, y equals 4x minus 1. Now moving on to the staircase frames, we look at a different pattern. Whereas the number of steps increases by 1 each time, it's a +1 pattern, the number of rods increases at a different rate, +6, +8, +10, and so on. And some students describe this as increasing by 2 more each time. But what they were also able to explain was this is not a linear pattern because there's not a constant rate of change. Now this is also shown by the graph, which is not linear, but it curves upward to the right. And again, students were asked to explain that in their own words in the questions that follow. I hope this video helped you with problem 1.3. It is one of 4 videos in this series, and you can see those other videos on my website, or you can email me with questions at this email address.